Hello everyone and welcome to How-FixIT. If your DJI Mini 5 Pro crashed, fell into water, has a damaged gimbal, broken arm, vision sensor error, motor issue, or simply refuses to take off, this guide will help you understand what may be wrong and how to reach the damaged part. In this video, I will completely disassemble the DJI Mini 5 Pro and remove almost every major module inside the drone. This includes the upper and bottom shells, gimbal camera assembly, core board, front and downward vision sensors, arm hinge shafts, and other internal components. As I take the drone apart and reassemble it, I'll explain each module's function, the errors it can cause, and how to diagnose, replace, and install damaged parts correctly. To repair the DJI Mini 5 Pro, you'll need a precision screwdriver set, and for safe disassembly, plastic pry tools and tweezers. For reassembly, I recommend using electronics-grade silicone or a hot glue gun. I've included links to the tools, electronics-grade silicone, and replacement parts in the video description below. I also recommend using a magnetic mat to organize all screws and parts during the repair process. The DJI Mini 5 Pro uses many small screws of different sizes, and keeping each screw in the correct location will make reassembly much easier. A magnetic mat also helps hold small metal parts in place and reduces the risk of losing screws or making assembly mistakes. So, let's get started. Before starting the disassembly, make sure the drone is completely powered off and remove the battery. The first step is to remove the upper body cover. You need to remove the 4 screws that hold the top cover in place. 2 of the screws are hidden under stickers, so peel off the stickers and remove the screws underneath. The other 2 screws are located behind the camera gimbal. Now you can begin opening the drone's top cover. Start from the rear side where the charging port is located. I recommend using a plastic spudger to create the first gap. If you use a metal tool, be very careful not to damage or crack the housing. This step is important if you need to replace the upper shell, middle frame, bottom cover, or inspect the drone after a crash. Cracks in the shell, broken mounting points, or distorted frame geometry can cause vibration, gimbal alignment problems, vision sensor errors, or unstable flight. When opening the upper cover, be careful and do not pull it away too quickly. The upper shell has an antenna connection, and lifting the cover too aggressively may damage the antenna cable or connector. The antenna cable is additionally secured to the connector with UV cured adhesive. This adhesive is quite strong, but it can be softened with gentle heat. If you don't have a hot air station, you can use a hair dryer. Just avoid overheating the plastic parts, because they can deform. Now you can remove and replace the upper cover. Next, I'll disconnect the gimbal signal cable and remove the bottom cover so I can take out the gimbal camera assembly. First, heat and peel off the black protective film. Loosen the screw and remove the metal bracket, then disconnect the gimbal signal cable from the drone's main board. Remove the 2 screws securing the upper front sensor module. Lift the module slightly, but do not remove it completely from the drone frame yet, because it is still connected by ribbon cables. I did not disconnect the ribbon cables from this module because it is not necessary for removing the gimbal camera assembly. However, one of these cables is very thin, so if you are not confident that you can lift the module safely with the cable still connected, disconnect the cable first. The gimbal signal cable is also secured to the body with adhesive. Heat the adhesive carefully and release the cable from the frame. Remove the 2 screws securing the upper gimbal camera mounts to the drone frame. Now the gimbal cable and upper mounts are free. We can move to the bottom side of the drone body to access the lower gimbal mounts. You can place the front vision sensor module back into the drone body and loosely cover the top opening, but do not snap the top cover into place. Remove the 2 screws and take off the lower cover of the drone body. After removing the bottom cover, we gain access to the lower gimbal mounts. Remove the rubber dampers from the middle frame. Now you can remove the complete gimbal camera assembly from the drone body. If the gimbal bracket is stuck and does not come out of the frame, gently press on the side of the bracket to release it. The gimbal is one of the most fragile parts of the drone, and after a crash it is often one of the first components to fail. The gimbal signal cable is one of the first parts you should inspect. If this cable is damaged, loose, or not connected properly, the drone may show gimbal errors, abnormal camera movement, no image transmission, or the gimbal may fail its startup self-check. Next, inspect the brackets, gimbal motors, rubber dampers, and camera module. If your DJI Mini 5 Pro crashed and the camera is shaking, stuck, tilted, not stabilizing, or shows errors such as gimbal motor overloaded, gimbal calibration error, or gimbal IMU data error, this is the first module to check. You can replace the complete gimbal camera assembly. However, keep in mind that replacing the gimbal camera assembly may require professional calibration or DJI service tools. The good news is that the gimbal camera assembly can be disassembled, and many of its internal components can be replaced separately. This can be more cost-effective than replacing the entire gimbal module, and in some cases, additional calibration may not be required. In a separate guide, I'll show how to disassemble the gimbal camera assembly and replace its internal parts. I'll add a link to that detailed gimbal repair guide in the video description below. Now let's move on to removing the core board. Start by removing the adhesive that secures the cable connectors, then disconnect all cables from the board. Remove the 3 screws securing the core board to the drone frame and take off the heatsink. There is thermal paste between the heatsink and the main board. Try not to contaminate or remove it unnecessarily. If the thermal paste is damaged or dirty, it should be replaced during reassembly. On the back of the main board there is a heat dissipation adhesive sheet that holds the board in place. To remove the board, you can peel this black adhesive sheet away from the frame or heat it with a hairdryer and carefully separate the main board from the adhesive. Before lifting out the core board, pay attention to the small folding arm detection switch located in this corner. This switch detects the position of the right rear arm and controls the automatic power on feature. Be careful not to bend, break, or catch this switch on the drone frame during removal. If this folding arm detection switch is damaged or misaligned, the drone may think the arm is still folded and show an arm not deployed error or refuse to take off. The core board is the main control board of the drone. Many systems connect through this board, including the gimbal, IMU, vision sensors, ESC board, antennas, and other internal modules. If the drone shows multiple errors at the same time, for example, IMU initializing, abnormal sensor, gimbal attitude error, arm not deployed, no image transmission, or unable to take off, The problem may not be in all those modules separately. It can be caused by a loose connector, damaged socket, scratch trace, missing component, or damage on the core board itself. I've included a link to a replacement core board for the DJI Mini 5 Pro in the video description below. But keep in mind that core board replacement may require activation, controller relinking, DJI account binding checks, and professional calibration depending on the repair case. If your drone has water damage and you need to clean the board or prevent corrosion, you may need to remove the metal shields from both sides of the board. I covered the process of restoring a drone after water damage in a separate guide. If you are dealing with water damage, I recommend checking that guide. The link is in the video description. Next, I'll remove the upper front sensing module with the LiDAR and vision sensors. Since I had already removed the 2 screws securing this module to the drone frame and disconnected the main cable from the core board, the only remaining step is to soften the adhesive and disconnect the cable from the IMU module. The IMU cable is very thin and delicate, so disconnect it carefully. Now lift the module slightly and remove it from the drone frame. This module is responsible for forward obstacle detection and part of the drone's vision system. On the Mini 5 Pro, one side includes the forward-facing LiDAR system, while the other side works as part of the vision or depth sensing system. Each sensor is connected with a separate cable, so in some cases you can replace individual sensors instead of replacing the entire module. If this module is damaged after a crash, the drone may show forward vision sensor errors, obstacle avoidance warnings, abnormal sensor messages, or the obstacle sensing system may stop working correctly. If the sensor windows are scratched, cracked, dirty, or the module is misaligned, cleaning may not be enough. The sensor or its mounting position may need to be inspected or replaced. However, vision sensor replacement is sensitive. If DJI Fly automatic calibration does not clear the error, this may become a service-level calibration issue. Next, use a T3 Torx screwdriver to remove the 2 screws securing the IMU module to the drone frame. The IMU, or Inertial Measurement Unit, helps the drone understand its position, movement, angle, and flight orientation. If the module or its cable is damaged, the drone may show IMU calibration required. IMU initialization errors, gyroscope errors, unstable hovering, drifting, or the aircraft may refuse to take off. After a crash, even if the module looks fine, a loose connector or damaged flex cable can still cause IMU-related errors. I've included a link to the replacement module in the video description below. Now use a T3 Torx screwdriver to remove the 2 screws securing the internal speaker. The speaker is a separate internal module. It is not usually the reason for flight failure, but if it is disconnected or damaged, the drone may lose warning sounds, startup sounds, or audible system alerts. If the drone was exposed to water, the speaker area should also be checked for moisture and corrosion, because water can stay trapped around small acoustic openings. Next, I'll remove the lower vision sensor module. Remove the 3 screws securing the module to the drone frame. Carefully peel off the part of the cable with the side button from the drone frame. The section of the cable with the LED is secured with additional adhesive. Soften the adhesive before separating the cable from the drone frame. This lower module is important for positioning, landing protection, and stable hovering close to the ground. On the DJI Mini 5 Pro, the lower vision system is connected together with the fill light and side button area, so be careful with this cable and do not pull it by force. If this module is damaged, loose, or misaligned, the drone may show downward vision sensor errors, unstable hovering indoors, poor landing behavior, abnormal sensor warnings, or positioning problems when GPS is weak. After a crash or water damage, inspect the lower vision cameras, the fill light, the cable, and the connector. If the module is physically damaged or the cable is torn, it may need to be replaced. I've included a link to the replacement lower vision sensor module in the video description below. Now I'll show you how to remove the rear arm hinge shaft. The two rear arm shaft screws are hidden under the sticker. First, remove this sticker, then unscrew the screws underneath. Once the screws are removed, press down on the shaft from the back and remove it from the frame. The rear hinge shaft is part of the folding arm mechanism. If the drone crashed and one rear arm feels loose, does not lock correctly, has play in the joint, or sits at the wrong angle, the hinge shaft or arm structure may be damaged. A damaged hinge can cause vibration, unstable flight, motor alignment issues, or arm position errors. A link to the rear arm hinge shaft is provided in the video description below. Next, I'm going to remove the front arm hinge shaft. First, remove the two screws securing the arm to the shaft. After removing the two screws, separate the drone arm from the shaft. This gives you access to the three screws securing the shaft to the drone frame. Remove these three screws, then take out the front arm hinge shaft. The front hinge shaft works the same way, but it is also located near important antenna and wiring paths. If the front arm is broken, loose, bent, or does not fold and unfold correctly, inspect the hinge shaft, arm shell, screws, and internal cable routing. A small crack near the hinge or a shifted shaft can change motor alignment and cause vibration, unstable flight, motor errors, or poor flight performance. I've included a link to a replacement front arm hinge shaft for the DJI Mini 5 Pro in the video description below. At this point, the main replaceable modules have been removed from the drone body. To remove or replace the ESC board, motor arms, motors, or the main frame, soldering is required. The motor wires are connected to the ESC board, so this part of the repair is more advanced than simple module replacement. If your drone shows motor unable to rotate, motor stuck, ESC-related errors, max power load reached, or one motor does not spin correctly after a crash, inspect the propellers, motor shafts, arm alignment, motor wires, and ESC board. Before replacing the ESC or motor arms, make sure you have soldering experience and take photos of the original wire routing and wire order. Incorrect soldering, pinched motor wires, or damaged antenna routing can cause new errors after the repair. This completes the disassembly process of the DJI Mini 5 Pro. At this stage, you can inspect each module, identify crash or water damage, and decide which part needs to be repaired or replaced. A detailed disassembly and repair guide for the gimbal camera module will be covered in a separate video. Before starting the reassembly, I recommend taking a short break. A full teardown requires a lot of attention, and the reassembly process needs the same level of focus. Give yourself some time to rest, check that all parts are organized, make sure no screws are missing, and then continue with the full reassembly process. Now let's put the drone back together and bring it back to fully working condition. First, install the front arm hinge shaft, place the front hinge shaft back into the drone frame and align it with the screw holes. Then install the 3 screws that secure the shaft to the frame. After that, connect the front arm to the hinge shaft and secure it with the 2 arm screws. After installation, check that the rear arm folds and unfolds smoothly. Also make sure the motor wires and antenna routing are not pinched inside the hinge area. Next, install the rear arm hinge shaft. Position the rear arm shaft inside the frame, align it with the rear arm, and press it into place. It helps to fold the arm slightly while installing the shaft so the hinge can sit correctly in the frame. Install the rear shaft screws and check that the rear arm moves smoothly without play. If the arm feels loose, stiff, or sits at the wrong angle, check the shaft position before continuing. Now install the lower vision sensor module. Route the lower vision cable through the frame exactly as it was originally installed. This cable is difficult to position, so take your time and do not force it. Place the lower vision sensor module into position and install the 3 screws. Make sure the fill light and side button section sit flat against the frame. If this part is loose, the bottom cover may not fit correctly and the side button may not work properly. Next, install the internal speaker. Place the speaker back into its position and secure it with the 2 screws. Now install the IMU module. Place the module into the frame and secure it with the 2 screws. Next, install the upper front sensing module. Position the module into the front section of the frame and connect the IMU cable to it. This cable is very thin and soft, so do not pull, bend, or press it too hard. Now install the core board. Before placing the core board into the frame, check that all cables are routed in the correct direction. Lower the board carefully and make sure no flex cable, antenna cable, or wire is trapped underneath. Pay attention to the small folding arm detection switch on the core board. Do not catch or bend this switch during installation. If it is damaged or misaligned, the drone may think the arm is still folded and refuse to take off. Next, install the heatsink. Check the thermal paste or thermal interface material between the heatsink and the core board. If it is clean and still in good condition, keep it in place. Additionally, you can lightly gather the paste for better contact. If it is dry, contaminated, or damaged, replace it before installing the heatsink. Place the heatsink back onto the board and secure it with the screws. After the board with the heatsink is seated correctly and secured with the screws, reconnect all cables one by one. Now let's talk about securing the connectors and flex cables. During reassembly, some cables, connectors, and small modules need to be secured again with adhesive. For the best result, use electronics-grade RTV silicone, specifically neutral cure silicone. It stays slightly flexible after curing, helps absorb vibration, and keeps flex cables or connectors from coming loose during flight. If you don't have electronics-grade silicone, the hot glue sticks can be used as an alternative. I recommend choosing durable and weather-resistant glue so it can provide basic vibration support for connectors and cables. I left a link to the recommended glue in the description, but hot glue is less precise, sets quickly, and must be applied very carefully around small connectors and fragile flex cables. I do not recommend using regular construction silicone, especially silicone with a strong vinegar smell. This is usually acid cure silicone, and it can be unsafe around electronics because it may release corrosive vapors while curing. When securing the cables, avoid using too much adhesive near the gimbal signal cable connector. If too much adhesive gets into this area, the cable may not seat properly. If that happens, let the adhesive cure or cool down, remove the excess, and apply only a small amount. Next, secure the upper front sensing module cable and the internal speaker cable to the board. Also secure the other side of the upper front sensing module cable together with the upper shell antenna cable before closing the drone body. Turn the drone over and apply a small amount of adhesive near both sides of the fill light area. Be careful not to use too much, because excess adhesive may prevent the bottom cover from fitting correctly. Now install the gimbal camera assembly. First, route the gimbal signal cable along the cable guide on the gimbal mount. Lift the upper front sensing module slightly, place the gimbal into the middle frame, and guide the gimbal signal cable through the correct opening. Once the gimbal is seated, secure the upper gimbal mounts with the 2 screws. Then route the gimbal signal cable to the core board and connect it. Secure the gimbal signal cable to the drone frame with a small amount of adhesive. Now place the upper front sensing module back into position and secure it with the 2 screws. Turn the drone over and seat the rubber dampers into the middle frame. Be careful not to puncture or tear them with tweezers. Before continuing, make sure the gimbal moves freely and the signal cable is not twisted, pinched, or stretched. Put the side button back in place and check for smooth pressing. Next, install the lower cover. Place the lower cover onto the drone body and make sure the latches on the bottom cover are not bent and correctly positioned. Do not force the cover if it does not sit flat. Once everything is aligned, install the lower cover screws. Install the metal bracket over the gimbal signal cable and secure it with a screw. Now install the upper cover. Before closing the top cover, connect the antenna cable from the upper shell and secure it with adhesive. Make sure the antenna connector is fully seated and secured. Then place the upper cover onto the drone body and gently press around the edges to snap the clips into place. Do not force the cover if one side does not close properly. Check for misaligned clips and make sure the latches on the upper cover are not bent. Finally, install the 4 top cover screws. Now the drone is ready for the first test power on. Insert the battery and power on the drone. Watch the gimbal startup self-check, confirm that the camera image appears, and check the DJI Fly app for any required calibrations. Then perform a short controlled test flight in a safe open area. If you found this guide helpful, give us a thumbs up and subscribe for more tech tips and guides. Visit our website for more insights and do-it-yourself guides. Remember, every tech challenge is an opportunity to learn and grow. Thanks for watching How-FixIT, and we'll see you in the next one.